In this presentation we're going to look at Laplace transforms. What we're going to do is sketch the graph and find the Laplace transform of the following function. F of t equals sine of 4 pi t when the function exists between 0 and 2. Otherwise it is 0. So what we do first off is sketch it. So this just has a sort of limited duration to this function. It will exist between 0 and 2, but it'll be 0 otherwise. So what we want to do is come up with a sketch of this, but we need to know the period of the function. So just remember, if we have a function like this, f of t equals sine of k times t, the period of the function can be derived as follows. Period equals 2 pi over k. Okay, so in this case, here we have k is 4 pi. So the period of the function is 2 pi over 4 pi, and that is equal to half, or 0.5. Okay, so that's the only thing we really need to know about this function, the period of the function. We can sketch it now. It's just a normal sine wave in terms of drawing it out. So there I have it there. So it exists between 0 and 2. Okay, so it'll cut out at this point here. Okay, it'll become 0 after this point here. This is the line t equals 2. Okay, and after that point, it'll become 0. So it's just there on the x-axis or the t-axis. But in the meantime, it will undergo the period is 0.5, so it can fit in 4 full periods in between t equals 0 and t equals 2. So essentially what I've just done there is drawn in the 4 periods. So this is the first period here between 0 and 0.5, and the period there is 0.5. There we go. 0.5 and 1, 1 and 1.5, and then finally 1.5 to 2. Okay, it's a bit hard to draw in a sort of freehand, but that's pretty good. Now, the function is only active between time t equals 0 and time t equals 2. So what we're going to use is the Heaviside step function. Okay, so if a function is active between time 0 and 2, we're going to use this function here to as a sort of way of getting rid of the cases. So between 0 and 2, if it's outside those boundaries of 0 and 2, this function here will give you 0. Inside it will give you 1, and you multiply that by your other function. So this is the Heaviside step function. It's actually sort of easier used in practice. Just as sort of quick remarks, u of 0 is 1 and u of infinity is 0, and we're also going to use u of 2. Okay, those are quite important to remember. Okay, so I have something separately done on the Heaviside function there if you just want to have a check on that. Let's go down here now. So the function can be rewritten as u of 0t, this is u of 0t, I just put it in there as 1, minus u2 of t, and we're going to multiply it by the main function there, sine 4 pi t. Okay, so that's how we can rewrite the function. Okay, we don't need to get into cases. This sort of form here will this form here is sort of correct for both cases that we've seen earlier. For all cases of t greater than 0, this form it will be fine. Okay, so again, u0 of t, I just replaced it there with 1. So what I'm going to do now is just rewrite the function here again. So we're just going to multiply it through. So I'm going to multiply 1 by sine 4 pi of t, and then u of 2t sine 4 pi of t. Just multiply it through and I get this. Okay, so sine 4 pi of t, easy enough, and u2 of t minus sine 4 pi t. So we have two expressions there. Okay, now this first function here, sine 4 pi of t, that's actually very easy to get. That's a very straightforward Laplace transform. Okay, the second one here, this one here, this needs a little bit of work. Okay, u2 of t sine of 4 pi t. Okay, so from the tables, this is the Laplace transform tables. We're going to use this form here. What we're going to say is that it is in the form f of t minus a, of a function of t minus a, times the Heaviside step function of a, u of at, okay, this part here. And so what we could do is use that form there. So this corresponds to the Heaviside step function part, u of at, okay, that part there, good stuff. Sine 4 pi of t, that would correspond to this part here. But you notice one thing, sorry, just a sort of quick remark, this Laplace transform here, it will work out to be e to the minus as of times f of s, okay? That's relatively easy. So all we have to do is actually sort of set up the function properly. But you notice now that it's not, there's one sort of major problem here. What we have up here, I'll just draw it in here, is a function sine 4 pi t. That's, and what we need down here is f of t minus 2. In this case, actually, sorry, something I should have just to sort of point out, make it very explicitly, a is going to be equal to 2 from now on here. Okay, so we need a function in terms of f of t minus 2. Okay, so essentially what we need to do here is rewrite sine of 4 pi t as a function of t minus 2. Okay, now what's useful here is trigonometric identities, and I'll get to them shortly. But essentially what we're going to do here is set up a little trick. Okay, so something that will help us here is we're going to rewrite sine of 4 pi t, and I've broken it up in such a way to make this absolutely crystal clear. So what I'm going to do here is 4 pi and then t, but what I'm going to do is split up 4 pi and as one part, and I'm going to split up t minus 2 plus 2. Okay, so I'm going to make this one term, t minus 2. Let me use red pen there actually, and then just 2 as the other term. So t minus 2 plus 2, and that will give you bring you back to t. So splitting it out a bit further, we have 4 pi t minus 2 and 4 pi times 2, or 4 pi t minus 2 plus 8 pi. Okay, so far so good. Okay, now the sine of 4 pi t is the sine of that. Sine of 4 pi t minus 2 plus 8 pi. Okay, I'm going to use this this trigonometric identity here. Sine of a plus b equals sine a cos b plus cos a sine b. Okay, sine a cos b plus cos a sine b. Now, important thing here is b is going to be equal to 8 pi. Okay, but the cos of 8 pi is 1. Okay, so this part here is going to necessarily reduce to 1, and sine of 8 pi is 0. So this is going to be 0 over here, and necessarily this whole side is going to be 0. Okay, so in this particular instance, sine of a plus b is just equal to sine of a. Okay, so sine of 4 pi t in this case is equal to sine of 4 pi t minus 2. Now you might have sort of spotted that actually earlier on and just sort of said, did we need to go through all of this? In this particular instance, no, we didn't really, this trigonometric identity stuff. But there are other questions where this is useful. Okay, so that's why I actually sort of included it anyway. Okay, so here's our function again. F of t equals sine of 4 pi t plus u2. There we go. This is we're in the home run now. So Laplace transform of sine 4 pi t, that is equal to here. This is in the form sine of at. Okay, so the Laplace transform of that, sine of 4 pi t, is equal to 16 pi squared. Is it? No, sorry, it's 4 pi over s squared plus 16 pi squared. Okay. The second one, the Laplace transform, or the other part, is what we have here is let's actually do it on a new sheet. F of t minus 2 u2 of t equals e to the minus 2s of f of s. Okay. Now, what is going on here? This f of s is the Laplace transform of f of t. Okay. Here f of t is sine 4 pi t. Okay. It's essentially what we have here is just replace, well, it's just what we have originally, sine of 4 pi t minus 2. Just replace the t minus 2 with t. Okay. And so that goes in here. Just take out essentially what we do here is just replace sine of, or t minus 2 with t. We just get sine of 4 pi t. So that's actually the same function. So e to the minus 2s is the only thing we have to add in. So for the second part, the Laplace transform is this part here is e to the minus 2s. I'm just going to put in second part here. This is the second part over here. 4 pi over s squared plus 16 pi squared. Okay. So we can add them together and simplify. So the overall Laplace transform is as follows. 1 minus e to the minus 2s times 4 pi over s squared plus 16 pi squared. That is Laplace transform. We had the sketch done earlier. There's a lot of little tricks to this question. We can put that in brackets there as well. And that is the answer there. So that's the inverse Laplace, or the Laplace transform of that function there. So Heaviside functions, step functions, and trigonometric identities.